First year B Farm, roll number 1 to 11, will present a short video on the topic Methods of Expressing Concentration in Pharmaceutical Analysis.
All present, the topic given to us, as Sir has mentioned, is methods of expressing concentration.
Our team members are Atharva Gogavale, Isha Chudasma, Disha Bangera, Anand Upadhyay, Abdul Adhikari, Sharvari Gujarati, Doreen Fernandez, myself Babita Dubey, Ishan Michael and Aisha Sheikh. So let's start understanding the topic. Anand, over to you.
Yes, so the first one which we will see is normality. In chemistry, it is one of the expressions used to measure the concentration of a solution. It is abbreviated as N and sometimes referred to as equivalent concentration of a solution. The formula goes as N equals to EQ divided by V.
So in this formula, EQ is number of gram equivalent of solute and V is volume of solvent in liters. Gram equivalent weight is the measure of reactive capacity of a molecule. The solute role in the reaction determines the solution's normality. Next are Aisha and Disha, who will start explaining the second subtopic. Over to you.
And Abdul, your explanation was fabulous. Let's come up to the next topic, molarity. Molarity is a number of mole of solute dissolved in 1 liter of solution. In chemist, a mole is a unit of measurement for the chemical substance. The scientific noun molarity describes the concentration of a substance as measured by the number of moles divided by the volume of a solution. So, chemists might be talk about the molarity of a sodium chloride in 1 liter of water. Molarity come from moles. So, keep in mind capital M indicates molarity where small m indicates molality. Over to you, Disha.
The concentration of the solution tells you how much solute has been dissolved in the solvent. It is important to note that molarity is per liters of solution, not per liters of solvent. For example, if 1 mole of salt were added to 1 liter of water, the resulting solution would not be 1 molar. Isha will continue and explain you all the third method of expression.
Very well explained, Aisha and Disha. One more method we'll be seeing is molality. Molality, expressed as small m, is defined as the number of moles of solute per kilogram of solvent. The formula is given as m, which is molality, equals to moles of solute by kilograms of solvent. You have to remember that molality is used to measure the moles in relation to the mass of the solvent and not the mass of the solution. Sometimes there are also instances where the solutions contain more than one solvent. In such cases, we consider or define the molality of the mixed solvent. Alternatively, the units are expressed as mole solute per kilogram mixed solvent. Here we can see a question as an example. How will you prepare 0.01 m NaOH solution? So, 1 m equals to 40 grams of NaOH dissolved in 1000 grams distilled water. Therefore, 0.1 m will be equal to 4 grams of NaOH in 1000 grams distilled water. Therefore, the answer will be 0.01 m equals to 0.4 grams of NaOH dissolved in 1000 grams distilled water. And this is how we will prepare 0.01 m NaOH solution. Over to you, Ishan.
I will be explaining you guys the fourth way of expressing concentration, which is percent concentration. It is the amount or the volume of a chemical or a compound per 100 ml of a solution. It is a relative expression of a solute to solvent. X amount by 100 ml is X percent. Percent solution is a convenient and easy way to record solution concentration. The percent can further be determined in one or two ways. The ratio of the mass of the solute divided by the mass of a solution, or the ratio of the volume to the solute divided by the volume of a solution. Suppose that a solution has prepared by dissolving 25 gram of sugar into 100 gram of water. The percent of the mass will be calculated by percent by mass equals to 25 gram of sugar by 125 gram of solution into 100 is 20%. Hope you all understand the concept. Coming up next is Doreen. Over to you.
Thanks, Ishan. We'll now be looking at formal concentration. The concentration unit, formol, is similar to the more familiar molar concentration, in that it is calculated as the number of moles of a substance in a liter of solution. Formal concentration are noted with the symbol F, and the formula is weights per liter of solution. It indicates moles of the original chemical formula in the solution without regard for the species that actually exist in the solution. For example, the formal concentration of a solution of glucose is the same as its molarity. A solution that is 0.0259 m in glucose is 0.0259 f in glucose as well. Over to you, Atharva.
So, the last method of expressing concentration is ppm, that is parts per million. In various fields, parts per million is a set of pseudo units to describe small values of miscellaneous dimensionless quantities like mole fraction upon mass per fraction. ppm, that is parts per million, is equal to grams of solute upon grams of solution into 10 raised to the power of 6. 1 parts per million is equivalent to absolute fractional amount multiplied by 1 molar. A better way of thinking of ppm is to visualize putting 4 drops of ink in 55-gallon barrel of water and then mixing it. This would produce an ink concentration of 1 ppm.
To give us more clarity, we can say 1 inch in 16 miles and 1 second in 11.5 days. One more part is ppb, which is 1 part in a billion. Since this is much lower concentration, some analogies would be 1 sheet roll in a toilet paper from Mumbai to Kashmir and 1 peach salt in 10-ton potato chips.
Well explained, Atharva and Sharvari. So this concludes the focus of discussion of our group. To end, I'd like to highlight different units are used to express the concentration of a solution depending on the application. The concentration of a solution is the quantity of solute in a given quantity of solution. It can be expressed in several ways like normality, number of gram equivalent of solute dissolved in 1 liter of solution, molarity, which is moles of solute per liter of solution, molality, the number of moles of solute per kilogram of solution, percentage solution, it is the volume of chemical compound per 100 milliliter of solution. Formal concentration is similar to molar concentration, which is the number of moles of substance in a liter of solution, and parts per million is milligrams of solute per kilogram of a solution. Thank you for your time and attention today.
Peace.